So y equals 2 cotangent of 3x minus 2. If we recall the structure of the sine and cosine graphs from yesterday, a plus b, trig function c times x minus d. Insert your favorite trig function here. Alright, so it could be tangent, cotangent, secant, cosecant, doesn't matter. Alright, but they all have the same criteria for moving things. So if I'm adding or subtracting a number from the overall function, it's going to move the graph up or down. If I'm adding or subtracting inside here, it's going to be moving left to right, opposite of what you see. So minus d, d is always going to be opposite the sign that you see in there. So, and just like yesterday, this has to be x, so if there's anything in front of x, that's what c becomes. So looking at this, c is going to equal 3. But I have to extract the 3 to get the correct d, so make sure that happens. So, and just like yesterday, I want to create this exact structure. I want to put a number for every slot a, b, c, and d. So if there's a equals 0, I want to put 0 plus. If c equals 1, I want to put 1 times. So those understood numbers, I want to actually see those on there. So y equals a is 0 plus b is 2 cotangent, and I'm going to factor out the 3. And that divides each object by 3. So 3x divided by 3 is x. 2 divided by 3 is going to be 2/3. So that's priority 1, is to get the equation in this structure where I can very easily identify the values of a, b, c, and d. In this case, a is equal to 0, b is equal to 2. Those numbers have influenced the y-axis values. C is equal to 3. Which means in the case of a cotangent or tangent, the original period is pi. So the new period is going to be pi over c. So the period in this case is going to be pi over 3. And the per dash is going to be pi over 12. And finally, d is equal to the opposite of this number. So it's negative 2/3, so d is going to be positive 2/3. And that represents my starting point. So c and d influence the x-axis. I'm going to start here and go up pi over 12 per dash to get all my stuff. Remember with cotangent and tangent, we want to have 8 dashes. And just like yesterday, I don't want to put a y-axis on here until I establish where I'm going to be starting. We're starting at a positive 2/3, so I can go ahead and put the y-axis way over to the left like normal. If d happened to equal a negative number, I'd want to put the y-axis somewhere over to the right a little bit more to allow some negative regions and positive regions to be graphed. 2/3 is 0.67 as a decimal. And if I type in my calculator pi over 12, that comes out to 0.26. So per dash is 0.26. Since 0.67 and pi over 12 don't interact very well, getting the pi over 12 as decimal is advisable. And just like yesterday, if these don't work out exactly right, I want to label each dash. Okay, so there's no x colon whatever in this case. You know, that's not even true. All right, I'm going to do a split graph here, so I'm going to put a break in the graph. 0.67 goes right there. That's my starting point, right? And then I got to have 8 dashes, equally spaced dashes, so I'm going to kind of ballpark it, kind of make them go the same distance. So that's 1, 2, this dash doesn't count, so that's like the y-axis, right? So dash 1, 2, 3, 4, 5, 6, 7, 8. If I go x colon pi over 12 or even 0.26, either one of those, that tells me that I'm starting here, but I'm going to go up by this much per dash. That's fine. The only time you really have to label is when they get on opposite sides of that y-axis. Then it's kind of hard to do, you know, unless you just look into it. Like the last example yesterday, if I remember right, we had a half. Started at negative a half. We had a half scale. It worked. It doesn't usually. So, you know, if you do happen to get on either side of the y-axis there, pretty much label each dash as necessary. All right, so I've got the x-axis figured out. The y-axis, we're going to have a center line of 0, and we're going up 2 and down 2. And remember, for tangent and cotangent, you don't want to go way up there, okay, because they're going up to infinity, down to negative infinity. So we go up a little bit, and that represents 2 and -2. And cotangent starts at an asymptote, so the 0 point and the 4th point and the 8th point are all asymptotes. Alright, and again, before it was the y-axis. So again, with these moving things over, you got to recognize the phase shift number as where the y-axis should be. That's your starting point. So the vertical asymptote goes in at my phase shift dash 1, 2, 3, 4. And then dash 5, 6, 7, 8. Also, positive B at dashes 1 and 5, so B is positive 2, so dash 1, 2, dash 5, 2. It's going to be negative B at dashes 3 and 7, so -2, -2, and 0 at dashes 2 and 6. So again, you follow the same point layout as you would a regular tangent or cotangent graph, just follow the same thing. But again, just realize the 8 dashes, when I say dash 1, it actually looks like dash 2.
Yeah.
The phase shift is the starting point, that's the origin part, all right? And then we just connect those dots. And I did notice on homework, some of you guys were, I can't remember if it was you two or whether it was the other class, but we're doing that kind of stuff. You know, imagine you do that and then it's going to try and go through the asymptote, right? So keep in mind that when you graph these things, that they should kind of bend so they're going up and down. So you want to bend it that way and bend it this way when you draw it. I didn't count off for that, but just kind of try and create the correct shape. It doesn't have to be beautiful, just turning the right direction would be kind of good at this point. You know, that's the key on these problems. So, and that's the whole problem. So again, it's graphing a cotangent graph as it was, but it just kind of slid over to the right a little bit. That's what the phase shift did. Again, there is no centerline movement, so it didn't move up or down from normal, but it did move to the right.